we're going to continue to factor polynomials, one more video. And these are special polynomials. These are perfect square trinomials. So let's just do one of these perfect square trinomials so that you can see what happens when they're factored. And again, I'm going to fill my x squared term in the upper left, my constant in the lower right, and I'm going to start filling in my factors. I know that I get x squared when I do x times x. And I know that one way to get a 4 is to do 2 times 2. And because I want a positive 4, I may want them both to be positive or I may want them both to be negative. But since there's a positive number in the middle term, the positive 4x in the middle, that's kind of a clue to me that I'm going to need positive signs on my factors of 4. So now let's just make sure that this other diagonal is going to add up to a positive 4x. I got a 2 times x in this box because that's the intersection of 2 and x. I have another 2x in this box because the x column intersects with the 2 row. And when I add those together, I get a positive 4x. So the factors of x squared plus 4x plus 4 would be x plus 2 times x plus 2. Okay, let's try another perfect square trinomial. X squared plus 12x plus 36. I know my x squared goes in the upper left. My constant goes in the lower right. I know that to get x squared, I have to do x times x. And to get 36, I have to do 6 times 6. And because it's a positive 36 with a positive 12x in the middle, my guess is that I'm going to put positive signs on both of these 6's. So now I'm going to have a positive 6x in the upper right corner and a positive 6x in the lower left corner. And when I combine those two, I do get a positive 12x in the middle. So we got x plus 6 times x plus 6. And I bet some of you are looking at the third example and you're thinking that the answer is going to be x plus 8 times x plus 8. And I'd have to tell you that you are wrong. If you're looking for my pattern that I've been doing, I've thrown a little monkey wrench in the pattern, but it's not a big one. So to get x squared, again, I have to do x times x. To get 64, I can do 8 times 8. There are other factors of 64, but from what I've seen so far in this perfect square trinomial, it looks like the numbers that I have to choose have to be the same. Now this time my 64 is positive, but my x term in the middle, the 16x, is negative. So I'm going to use negative signs on my 8's instead of positive signs. And that will give me a negative x in the upper right-hand corner and a negative 8x. And a negative 8x in the lower left-hand corner. And when I add those two together, I get negative 16x, which is exactly what I want in the middle. Had I chosen positive 8's, okay, had I made the mistake and put the positive 8's here that some people thought I needed to, those would add up to a positive 16, which is not what I have this time around. I don't have a positive 16 in the middle of this one. So that's why I needed to use the negatives instead. Okay, so my factors this time, x minus 8 times x minus 8. And that can be written in a shorthand version if you use x minus 8 quantity squared, because there are two x minus 8's being multiplied together. Okay, some of you might be anticipating already what the solution is going to be to the next problem, or you might have an idea of what it's going to look like. If you are thinking that there should be minus signs in the middle, you are correct, because there's a minus sign in front of the 28. If you are thinking that there should be 7's here and 7's there, you are correct. If you're thinking that x needs to go here and x needs to go here, you are incorrect. That's not going to be enough to get us 4x squared. So let's just leave those x's there and finish the rest of this problem. Okay, my same terms are going in the same places as usual. I already know that we're probably thinking we're going to have negatives here. Now, the reason it's not just x is because x times x is not going to give us a 4x to the second power. And again, we're dealing with perfect square trinomials. So I'm going to guess I'm going to try 2x times 2x. instead of 4x times 1x. Now right here I will have a negative 14x when I multiply negative 7 by 2x. And again another negative 14x when I multiply negative 7 times 2x. And when I add those together, I do get negative 28x. So instead of having just an x here, I should have had a 2x minus 7 and another 2x minus 7, which I could also write as 2x minus 7 to the second power.